Alright, so we're going to battle our markers here, but we'll see what we can do. So with continued fractions, I want to write square root of 2 equals what?
So it's 1 plus, I guess, 1 minus root 2. Or root
no.
2 minus 1.
In general, what is a continued fraction?
So it's like x plus, and then these x's can be like a plus 1 over b. And then b plus 1 over c plus 1 over d.
Does A always necessarily have to be ones?
We want ones for the types of continued fractions we've studied. We want ones here. We always want it to be 1 over something, and we want these to just be integers.
Alright.
But there are other types of continued fractions, and some especially interesting ones where you don't have ones there all the time.
Yeah.
But for the ones we've looked at, we want ones there all the time. So what is the method for finding the continued fraction of something that my high school math teacher named?
Split, flip, and rat.
Split, flip, and rat. So what does split mean?
So you have to split it up into 1 plus.
So integer and non-integer.
Right, so integer plus non-integer. Flip means?
We write
Flip
the
it.
non-integer part as 1 over something.
Right, so 1 over, that's a good way to remember it. 1 over the non-integer part. And rat?
Kind of, you rationalize the non-integer part on the bottom.
Then rationalize. And then what do you do after you're done with rat?
You repeat.
You just do it again.
Okay, so let's do some splitting, flipping, and ratting. So what is square root of 2 in terms of the integer plus non-integer part?
So it's 1
1
plus root 2 minus 1.
1 plus root 2 minus 1. Alright, what happens when I flip?
So we do 1 plus 1 over root 2 minus 1?
Not quite. 1 over what?
1 over root 2 minus 1?
That's right, 1 over
Oh, yeah.
root 2 minus 1. Why have I not changed the value of expression when I do 1 over something?
Because fractions over fractions, the bottom part will flip up to the top
Yeah,
when you simplify.
okay.
And then we have to rationalize
1 over
our...
root 2.
Alright, what does that mean to rationalize this?
So we have to get the denominator to not have square roots.
Okay. Do you know what we do?
Do we square it?
If we square it, we'll change the value. So we have to multiply by a convenient form of 1.
So it could be like maybe root 2 over root 2.
Well, root 2 over root 2 is a good guess, but that's
then you
going to
have
leave us
a root 2 there.
a root 2 on the bottom. So what is the concept we're going to use here?
It's difference of squares.
The difference of squares. So we multiply by,
Multiply by root 2 plus 1.
okay, root 2 plus 1. And so I get a difference of squares on the bottom, which is 2 minus 1.
Yep.
Understand?
Yeah.
And on the top, so this turns, when I multiply by root 2 plus 1 over root 2 plus 1, I get 1 over
Root 2 plus 1.
root 2 plus 1. And now I repeat, what is root 2 plus 1 as a fraction? As an integer plus non-integer?
So it's
2
2
plus
plus
root
root
2
2
minus
minus
1.
Alright. 2 plus root 2 minus 1. And why does this make us happy?
Because we can do this is what we had before. So this is just going to repeat itself.
Yeah.
Just do it again.
1 over 2 plus 1 over 2 plus 1 over 2 plus all the way down. And it never stops. And why does that mean that root 2 cannot be written as a over b?
Well, if the fraction is never going to end, it's going to be infinite.
Okay. And why would a fraction with ratio of 2 integers, why would it stop when I did this?
Because
Well, 'cause then you-
whenever it stops, you can simplify it back
up to the top, and
Yeah.
then it'll be equal to a over b.
But here we can't because it goes on forever.
That's right. And so we get a never-ending process here. when you do continued fractions, when you start with fractions, along the way you get smaller and smaller fractions. So it sort of in some sense shrinks. So a over b will stop eventually. But this, we can see, doesn't stop.
Yeah.